I'm a physics teacher, and I've been teaching physics for about 15 years, let's say. Currently, I'm teaching grade 11 physics, and I'm also teaching the AP, or Advanced Placement Physics, our grade 12 version of it anyway. Recently, our school has had some PD sessions where they've introduced this idea of backward design or reverse design, where you start with the big ideas and you start to break it down to the little specific learning outcomes that you like the students to be able to do, and start with that and then design your classroom lessons and your classroom activities based on what it is that you'd like to look for once they're all done and done their work. You're always asking yourself the question as you go along, how will I know they've achieved this specific learning expectation? And it's really, you try and create an environment in the class where that will sort of bubble up and you'll see it, and hopefully you'll go aha, and you will have documented it before it goes away. Back in grade 9 science, the students were introduced to circuits, and now again in grade 11 we're coming back around to that issue. Overall, really any topic in electricity and magnetism is very conceptual. You cannot see electrons. Luckily, you can see wires and you can see light bulbs. So the plan was for them, for their homework, let's see what they remember. And I wanted to review specifically with them the schematic symbols they use when they draw circuit diagrams. So the homework, before, I used the software called nearpod. So before they came into class, they had to go to this website at home or use their phones and basically run through a bunch of questions, draw some stuff. They could use their fingers or a mouse and draw right on the screen. I thought that was pretty cool. And submit that, and then as the class began, I could refer back to that homework directly and lead straight into the lesson. So the first thing they had to do was look at a circuit that had a series and a parallel component to it, and they had to think about whether the current would change from this point on a wire to another point just a little further downstream, and then gradually build on that. Start with that, and then what about this point in the circuit and over here? They had to indicate on the screen, would the current be less than, greater than, or equal to the current at this other point in the circuit? And it just kind of built, and then eventually, after we got a sense of what our expectations were, they would then build a rule that would help them come up with the answer in any situation, whether the current be higher or less or the same in these different situations. The big picture that I wanted to achieve that class is for them to discuss with each other in small groups in twos, grappling back and forth, arguing about how things worked, and then gradually moving that out to larger groups, interacting with each other, and eventually also get a hands-on component where they're actually building circuits and seeing how those ideas that they've been talking about for the last half hour apply to an actual thing in front of them. I thought the software nearpod could help me for a couple of reasons. I like the fact that the students can access it on their mobile devices. I like how it has sort of a simple interface, and the main thing is it helped me assess their homeworks quickly. So I could, when they went into class, I could do a quick check, and I already knew that I don't need to review circuit schematic things. They were all getting those right. Whereas traditionally, they did homework and maybe I'd have to give them a quiz when they arrived, and that quiz might not get marked right away, and I just wouldn't get the feedback quite as quickly of how well they sort of knew the basics before I moved on. And then during the class itself, as the students worked in pairs on their iPads, I was able to control the pace of the whole class. I could slow things down if we needed to review a topic more. I could speed things up if clearly the students were getting it. And I had a clear sense of if they were getting it or not. Whereas previous to this, I think I would have just looked over the class, used their facial expressions, how engaged they were, and sort of got a sense of whether they knew this stuff or not. And I wasn't really guessing when I was using nearpod. I really had a good sense. And not only that, which students were having trouble, not just like an aggregate. And what that meant is the class could actually move on. I could then walk over to a student who I noticed had a trouble, or a pair of students, and say, let's go back 3 steps and look at what you did there. One of the things I was able to do with the nearpod software is when the students had agreed in their pairs that the current here would be greater than the current there, I could select just those students' pictures that they had drawn and share it with the rest of the class, and we could discuss it or have those students discuss it. It was a little mini layer of peer review that could just be seamlessly embedded in the progression of the whole class as we moved along. Sometimes I did put up student work that was not correct because there were enough students getting it wrong that it was a bit difficult for me, in fact, to find an exemplar. And I gotta say, I was very surprised. I ran this lesson twice with 2 classes, and with the first class, I was wrong. My expectation was that they understood this current law previously from their grade 9 work a lot better than they did. A few main misconceptions I had to work over right away. For example, some of them thought that the current would disappear in the resistors, and so that, in a sense, a light bulb gobbles up electrons and doesn't let them through. That meant that right off the bat they were starting to get questions wrong, and I would have never thought that would happen with these students. My expectation, and I've known them for a while now, all year, and some of them I taught before, even in grade 9, so I was surprised that they were weak in that one part, and I don't think I would have figured that out by a traditional lecture approach. It really stuck out like a sore thumb as soon as I was trying to take up the students' work and share it. And so instantly, on the fly, I adjusted the class and sorted that out. Now, on the other hand, in the afternoon, I did the same lesson, and with that class, I didn't have that problem, and we progressed a lot faster. And I would have never expected my 2 classes to be that different, and here they were, and I had that information right in front of me on my iPad as I was walking around the room. Based on the feedback I was getting on my nearpod screen right in front of me, I was able to alter my lesson pacing and plan live right on the spot. I had intended to spend only 3 minutes doing this, but instead I spent 10 because of the feedback I was getting instantly. And I would have never known that before if it wasn't for the visual representation of my students learning right there in my hand, where I could access it and flip through it. I think in the future, when I use this technology, I'm going to try and get as much assessment done live in the classroom as much as I can, so I have a little more time outside of class to do the things I enjoy more, such as making fun lessons like this. I'd rather be doing that than marking. I think I'm just starting to realize how I can use that power, can I call it a power, that superpower in the future.